Okay, so welcome to an extension example question using Pythagoras' theorem. Because this is such a hard example, I've decided to make it its own video because it does cover quite a few different concepts, especially using area formulas and Pythagoras. So let's have a go at reading the question. A square is perfectly inscribed inside a circle of radius 1. Find what percentage of the circle's area is covered by the square. Okay, so have a go, pause the video and then see what you come up with. And now let's go through the solution. So whenever we're finding the percentage of something, we're thinking about what percentage of the whole does our thing take up. So we're looking at the area of the square, and the whole thing we're looking at would be the area of the circle. So really this comes down to, we need to find the area of our square. So the area of our square, and then we also need to find the area of our circle. Now, one of these is way easier to find than the other. You can see that we've been given that the radius of our circle is 1. Now, we know that the area of a circle is given by the formula pi r squared, where r is the radius. And so we can say that since our radius is equal to 1, then our area is equal to pi times 1 squared, which is just going to give us pi. So there aren't any units, so we'll just say it's pi units squared. Now, the area of the square is a bit more tricky because to find the area of a square, we need to find the side length of the square. Now you can see, since we've only been given 1 as our radius, we don't have the side length of the square, which I will draw in red for you. So this is really what we're trying to find. Now, there is a cool thing that we can do though. Since this is a circle, we can draw multiple radii. So we can draw a radius from here to this corner, and we can also say that the length of it is 1. Now, hopefully you can see what's happening. We can see a right angled triangle here. Now, how do we know this is a right angle? Well, we know that the diagonals of a square will bisect each other at 90 degrees. So that is why this is a right angle. Now, you can see the red line is really just the hypotenuse of this right angle triangle. So I'm just going to draw this out over here again. I'll draw it like this so that it looks exactly like what it does on the diagram. So the red line is representing what we want. And we have the right angle, we have unit 1 and 1 unit here. So we're trying to find out the value of x. So write down the Pythagorean statement, which would be x squared, which is our hypotenuse squared, is equal to the first short side squared plus the second short side squared. And so we're left with x squared is equal to 1 plus 1, which is 2. So we can say that x is equal to root 2. Now that's only the side length of the square. To find the area of our square, we need to do side length times side length. Just remember that the area of the square is given by the formula s squared, where s is the side length. So here, the area of the square would just be root 2, that's this side, times another side. And since all of them are going to be the same, it would just be times another root 2. We know that root 2 times root 2 is going to give us 2. If you didn't know that, you can either put in your calculator or you can see that root 2 times root 2 is the same as just squaring root 2. And we know that squaring and square rooting are opposites. So we know that the area of the square is 2. We know that the area of the circle is pi. So to find any percentage, we do what we have over what the total and times that by 100%. So to find the percentage, we would say that the area of the square over the area of the circle times by 100%. So just put a little division over here. So area of our square is 2 and the area of our circle is pi, and then times that by 100%. If you are to put that in your calculator, you would get an answer of 63.66%. It doesn't actually tell us in the question whether they wanted to 2 decimal places or not. So you can either leave it like that Or if you want, you can just say to the nearest percentage. So that would be 64%. And so this would be our final answer. So hopefully you got a taste of what a hard Pythagoras question looks like, especially because it combines quite a few different mathematical principles. So we'll catch you in the next video, which will be about a couple of homework questions. So see you there.